Hello everyone, this is Greg from ChemCore. In this video, we're going to be going through a larger worksheet. We're going to be going through a worksheet made for alkyl halides, alcohols, and ethers. And so we're going to combine concepts that we had before. So learning the functional groups, the hydrocarbon functional groups, alkenes, alkynes, and adding on to the functional groups that we learned in this video. And so let's just write down the general formula to remind ourselves. Alkyl halides, or haloalkanes. I know some courses call them haloalkanes. I'm used to calling them alkyl halides, so I'll just continue calling them alkyl halides. Have the general formula Rx, where X could be fluorine, chlorine, bromine, or iodine. Alcohols have the general formula ROH. And now we should both note in both of these that R, or the carbon directly connected to X and OH, must be sp3 hybridized. And in ethers, the general formula is ROR. We usually put an apostrophe at the end just to show that they could be different or they could be the same. Now it should be to note that both of these direct carbons, so the carbons directly attached to oxygen, must only have hydrogen as a substituent. So let's write that down. If they have anything else other than hydrogen as a substituent, they're no longer ethers. They're actually going to be functional groups that we're going to study in the next two videos. So looking at the first couple problems, I'll go through these and kind of mention the ones that kind of pop out right away. I see these double bonds, meaning that this is an alkene group. This is an alkene group. And this is an alkyne. And this chlorine right over here is connected to an sp3 hybridized carbon, meaning that we do have an alkyl halide. The next problem, again, I see an alkene, another alkene, and an alkyne. I do see this bromine, and it's connected to an sp3 hybridized carbon, meaning that we do have an alkyl halide. The next group, I see our alkene. I see an iodine, that's a halogen, that is connected to an sp3 hybridized carbon, meaning we do have an alkyl halide. And then my next group is this benzene ring connected to this carbon, meaning that I do have a phenyl group. This carbon is not fully free, it's not CH2, meaning that this is phenyl. The next problem, I do see this double bond, which is an alkene group. I also see this triple bond, so alkyne. And this fluorine, which is connected to an sp3 hybridized carbon. And so this is an alkyl halide. The last two problems on this page, I see another alkyne, and an alkene. And this bromine is connected to this sp3 hybridized carbon, meaning that we do have an alkyl halide. And the last problem on this page, I again see an alkyne, I see an alkene, I see a halogen connected to an sp3 hybridized carbon, meaning that we do have an alkyl halide. But the last halogen is kind of a trick question. This is not an sp3 hybridized carbon. And now I think most courses do not require you to name this as its own functional group. You guys should at this point definitely be able to realize this is not an alkyl halide. I will name it an alkenyl halide. So an alkenyl halide, because the carbon bearing the halide is an sp2 hybridized carbon, or an ene, right? So it's kind of like alkyl, but alkene. So the ene, this little ene makes it a double bond. Easy way to remember it. And so, trick question. The last two fill-in problems, I see an alkyne group. I also see an alkyl halide. another alkyl halide. Both of these are connected to sp3 hybridized carbons, including this one as well. I see an alkene, and I see a benzene ring that is not connected to a free carbon, meaning that we have a phenyl group right over here. The last problem, I see an alkyne. I see these three chlorines. These are all alkyl halides, right? And so I'm kind of going to name all of these are alkyl halides each, but I don't want to rewrite it 3 times, so I'm just going to write that. We have an alkyne, another alkyne. We have both of these are alkenes. I have another alkyl halide over here. And I have this alkyl halide. Let me redo that because it looks like I'm pointing to that benzene ring. An alkyl halide. And then finally, this benzene ring that is not connected to a free carbon, meaning that we do have a phenyl. So a lot going on in the last problem. Again, if you're unfamiliar with your hydrocarbon functional groups, make sure to check out my previous video. I made a topic video on them, as well as I have a worksheet just isolating them. So just hydrocarbon functional groups. Make sure to go practice that because it's kind of, we're building up on concepts as we go. The next problem, which of the following is an alkyl halide? Now, I know we didn't talk about naming. We talked about naming a little bit, but all you should be looking for is one of the following: fluorine, chlorine, bromine, and iodine. And I see one answer choice in which I see chloro. Now, I don't expect you guys to know the name. It's kind of like critical thinking. Can you be able to identify one of your halogens, right? There has to be a name for it. Which functional group is in an alkyl halide? Well, literally the definition is Rx, in which X is any of your halogens. And so your functional group is a halogen atom attached to a carbon chain. In the next one, which of the following is a possible alkyl halide? This one you should be familiar with. Remember that again, we have either fluorine, chlorine, bromine, or iodine. And so in a molecular formula, we should see one of these. And the only answer choice in which we do see one of these is this one. We see is chlorine. And then the last one, which element is commonly found in alkyl halides? Well, the definition is a halogen. Now, I understand this is a weird question. I mean, you can also point to hydrogen. Hydrogen is definitely going to be common in alkyl halides. It's going to be common in most, if not all, organic compounds. So I understand that this is like, an iffy question. But you see where I'm reaching. I want you guys to realize that we do have a halogen is commonly found in alkyl halides. Now, again, I know this is kind of like a nomenclature type question, and you guys haven't really done nomenclature yet, but on kind of critically thinking and seeing this bromo, you should be able to understand that we have a bromine bonded to the second carbon. And I mean, that's where the second carbon comes from. And the next problem, which of the following is an alkyl halide with 5 carbon atoms? This is critical thinking from before. I know you guys didn't really go in depth with naming, but I did teach you guys how to name simple hydrocarbons. And so knowing 5 carbon atoms, you should be able to recognize pent. Pent means 5 carbon atoms. And so I see pent, and I also see that halide, that chloro. And so my answer choice is A. The next problem is a similar concept, except we're looking for an alkyl halide that on a carbon chain that has 6 carbons. And so from before, you should be able to recognize that this is hex. And so I only see one answer choice that has that chloro, that halide, and that hex. Which of the following is true about alkyl halides? Number 1, they only contain carbon and hydrogen? Definitely not. The whole point is that they contain a halide. They contain a halogen bonded to a carbon atom? Well, probably. They always contain an oxygen atom? Definitely not. They're a type of alcohol? Definitely not. And so our answer choice is B. Which of the following would be an example of an alkyl halide containing iodine? Well, iodine, is I, and so we're literally just looking for iodo. I know you guys don't know how to name, but critically think chloro, iodo, bromo, or fluoro. Well, the answer choice is probably the one that says iodo. In the compound 4-fluorocyclohexane, what atom is attached to the 4th carbon of the cyclohexane ring? Well, I'm probably going to guess fluoro, and so the answer is fluorine. In this sheet, we're going to move on to kind of bringing in alcohol. So I know you guys, at this point, the past 2 pages, we haven't really been focusing much on alcohols. Now we're going to start adding them in. And so the first question is asking which of the following is an alcohol. I know you guys don't really know the naming yet, but we can understand the answer by process of elimination. Methane ends in ane, so I know this is an alkane. It's definitely not the right answer. Butane also ends in ane, and so I know that this is also not the answer. And propene ends in ene, so I know this is an alkene. And so we're left with ethanol. And this is actually exactly how you can recognize alcohols. They end in -ol. But we'll go into depth about that in the next unit. In the next problem, we're asking which element is bonded to the oxygen atom in an alcohol. And so in our general formula, you should recognize that we have hydrogen bonded on one side, and the other side is going to be a carbon. And so any one of these choices should be correct, which, we only have one of these, which is hydrogen. In number 3, which of the following is a possible alcohol? Well, lucky for you, I already drew out the general formula. It's ROH. And so I only see one answer choice, which we see that ROH. Which functional group is found in alcohols? Well, that OH, you guys should know by now, is a hydroxyl group. Hydroxyl group, that's the name of it. And so the hydroxyl group is the functional group found in alcohols. Which of the following compounds is an alcohol with 4 carbon atoms? Remember that 4 carbon atoms has the prefix bute, my excellent protein bars. And so bute, we're looking for bute, but the proper ending is -ol. And so the answer choice is A. In the compound 2-propanol, what is attached to the second carbon? We have this -ol, meaning that attached to the second carbon, we should have a hydroxyl group, right? That's an alcohol. In the next problem, which of the following is true about alcohols? Alcohols contain a hydroxyl group. Yeah, that's the definition of an alcohol. Alcohols only contain carbon and hydrogen. Well, they also contain oxygen, so we know that's wrong. Alcohols are always gases at room temperature. No. If you guys, unless you guys have been living under a rock, most people have alcohol in their house in the form of drinkable alcohol or rubbing alcohol. They're definitely not gases, right? And so just by that, just common knowledge, you can probably eliminate C. Alcohols contain a nitrogen atom. They definitely don't. And so the answer choice is A. Which of the following alcohols has the smallest number of carbons? Well, I know you guys don't know naming, again, but number of carbons, we already know the prefixes for number of carbons. And so meth only has 1 carbon, and so this has to be the smallest possible alcohol ever, right? Not even on these answer choices, just in general. And so our answer choice is A. Which of the following is an alcohol with 3 carbon atoms? Your prefix is 3 carbons is prop. And so propanol would probably be the answer choice. We are now going to start adding ethers into the mix. Now, other than just like pointing and determining what the functional groups are, I kind of put a twist to this. It is one worksheet, so I don't want you guys doing the same thing. There's a couple requirements for each problem. You're going to write out the condensed structure. You're then going to specify whether the entire molecule is an alcohol, an ether, an alkyl halide, alkene, alkyne, or alkane. And then kind of a flashback to the first video in this unit, we're going to try to draw at least one constitutional isomer for the given compound. Now, there's probably many, many constitutional isomers for some of these problems. It's okay. You guys are allowed to use your creativity to draw constitutional isomers. If you want to check whether your answer is correct, find the molecular formula of the original and of your constitutional isomer. The molecular formulas must be the same, but the structures must be visibly different, or the attachment must be different. And so if that is true for the constitutional isomer that you drew, your answer is correct. I'm going to draw the very first constitutional isomer that comes to mind. And if you guys got it, well, high five, right? If you didn't, that doesn't mean you're wrong. Number 1, to write out the condensed structure, I know at the end I have CH3. Next I have CH2. Then I have that O, that oxygen. And then my terminal carbon on the other side is also a CH3. And so kind of looking at this follows that ROR, general structure, actually, apostrophe. And so this is definitely an ether. And so at this point, actually, a really interesting thing is that ethers and alcohols with the same number of carbons and obviously oxygens often tend to be constitutional isomers of each other. At this point, I can kind of mention that because you know what ethers and alcohols are. And so the very first constitutional isomer that kind of comes to mind for me is let's draw our 3 carbons and then add that OH to make it an alcohol instead. The next problem, to try to draw the condensed structure, a little tip I have with condensed structures, let's try to find like kind of like the longest chain, and then the rest are kind of like our attachments on the longest chain. And so my chain begins with that CH3. I then have that carbon with no hydrogens, which also has that OH, and then also a CH3. That's CH3 off to the top. After that point, we have this CH right over here that also has a branch of CH3. And then off down, we have CH2 and then our terminal CH3. And this is an alcohol molecule. We have that OH. And so I'm going to draw a constitutional isomer. I mean, the first idea is let's count how many carbons we have. 1, 2, 3, 4, 5, 6, 7. So 7 carbons, easiest constitutional isomer. Let's just draw 7 carbons and then an OH off to the side. The next problem, visually, at this point, you guys should be good with identifying that this is an ether. So a constitutional condensed structure for this would be CH3, then CH2, and then another CH2, and then another CH2. Then we have that oxygen. We have CH2, CH2, and that's CH2, and then our final CH3. And this is definitely an ether. And then again, really quick, easy constitutional isomers that you can make are alcohols with the same number of carbons. But that's a little boring. And so what I'm going to do is I'm just going to place the oxygen in a different spot. And so if I place oxygen 1 carbon here, that means I have 1, 2, 3, 4, 5, 6, 7 carbons left. Messed up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There we go. 7 carbons. In the next problem, very visual, kind of definitely an alcohol, right? Even without drawing the condensed structure, we know it's an alcohol. And going from left to right, I have that CH3. I then have a CH, and that OH is kind of a branch point, and our final carbon is a CH3. And so really quick constitutional isomer, let's just put all our carbons in a straight chain, and then OH coming off to the side. That's actually the exact problem we got in the next one. And so our condensed structure is going to be OH, or I can write HO, kind of reading left to right. Then I have a CH2, another CH2, and then a CH3. And so this is definitely, again, an alcohol. And, as a constitutional isomer, let's draw the problem that we had before. And so we have OH. In the next problem, again, this is a carbon. I know it might look confusing, but this is a carbon. Remember, we don't specify carbons. And so my condensed structure should be CH3, OH. So this is an alcohol. And there are no constitutional isomers for this. I dare you guys, try to draw a constitutional isomer. Did I spell that right? Constitutional isomers. There will be no constitutional isomers. You can't make another alcohol because no matter what, it's still the same thing. And you definitely can't make an ether because you only have 1 carbon. And so there are no constitutional isomers for this example. Kind of a trick question. In the next problem, we have our condensed structure is HO. Then we have a CH2, a CH2 right over here, another CH2, and then a terminal CH3 off to the side. This is most definitely an alcohol. And so since I have 1, 2, 3, 4 carbons, well, let's just try to draw these 4 carbons and then an OH attached to any other carbon other than the end. The next problem, I have CH3, then that CH right over here, that OH is a branch point, and then I have a CH2, and then the terminal CH3 off to the side. Again, this is an alcohol. And then literally any constitutional isomer, well, let's just draw this butanol and then an OH. And so, little trick, these two kind of are opposites, right? We kind of drew the constitutional isomer for the previous one. And the next problem, we have CH3 and then an O, another CH3. So this is definitely an ether. Now, a little tip earlier, remember that ethers and alcohols are constitutional isomers for each other. And so what we can draw is, well, draw any alcohol, and there's only 1 alcohol possible. And so realize that yes, our carbons would kind of lose one of the hydrogens, but we would gain that other hydrogen on the oxygen. And so really quick kind of rule of thumb is that ethers and alcohols with the same number of carbons are, as far as I'm aware, unless there's other functional groups going on, I'm pretty sure that they could be constitutional isomers. And so that's a little trick that you guys can keep in mind. The next problem off to the left, I have a CH3. I then have a CH2. And then at the end, I have Cl. And now, no matter how much you tried, you would not be able to draw a constitutional isomer. You could probably, if you were really desperate, try to draw a chlorine that has 2 bonds. But, in this course and in most courses, I don't think that we're going to consider a double bonded halogen possible. And so we can say that there are no constitutional isomers. In the next problem, my condensed formula should be CH2 from the left. Then I have the CH here, a CH2, and then my terminal CH3. And this is most definitely an alkene. Should be familiar with that by now. And so if you try to draw a constitutional isomer, well, let's try to draw these 4 carbons. And instead, we'll have that alkene in the middle. So very structurally, visually, they're definitely different. But the molecular formula is also going to be 100% different. The next problem, well, my condensed formula should just be CH2, 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 since they're kind of all interconnected. And so this is definitely a cyclic alkane. And now, drawing a constitutional isomer is going to be a little tricky. You wouldn't be able to draw another cyclic constitutional isomer, but what if you draw a branched one? If you were to count up all the hydrogens, you'd actually have extra hydrogens. And so to get rid of those, we can just add a double bond. And by adding a double bond, we're going to actually end up with the constitutional isomer. The next 2 problems, we have bromine, and then a CH2, CH2, and then finally a CH3. And so a constitutional isomer, well, first of all, this is an alkyl halide. And so a constitutional isomer that we can draw is going to be a bromine connected to the second carbon. The next problem, I have the carbon at the end. Remember that it also has a hydrogen. Then this carbon has no hydrogens. We have a CH2 over here, and then a terminal CH3. And so this is definitely an alkyne. And so a constitutional isomer that we can draw is, let's just place the triple bond in the middle. And so we still end up with 4 carbons and the same number of hydrogens. Now, in the last page, the first problem of the last page, I have from left to right, I have CH3, and then a CH, and then a CH2. And so this is most definitely an alkene. And so you wouldn't be able to draw another straight chain constitutional isomer, but you could draw this cyclic alkane. And by drawing it cyclic, you also kind of lose a hydrogen from the regular alkane form, and they should add up to the same number of hydrogens. In the next problem, we have CH2, and then the CH over here, an oxygen, a CH2, and then off on the terminal, we have CH3. And so this is kind of 2 functional groups. This is an alkene and an ether. Okay, and so a functional group that we can draw, a constitutional isomer, is, well, let's just connect it to 1 carbon, and then we'll have the remaining 3 carbons to the right, and then we could just, I don't know, draw the double bond literally anywhere, like right here, anywhere, or we could draw it here as well. And so that should be the same constitutional isomer. In the next problem, we have that CH at the end, all the way on the left. We then have this carbon right over here. We have CH2, 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 that's CH2, 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 2 more CH2s, and then a terminal CH3. And so this is definitely an alkyne. And a constitutional isomer that we can draw could look something like this. Just put the triple bond literally anywhere, as long as you have the same number of carbons. And the next problem, this is HO. We have a CH2, then this CH2, then this CH2, and last CH2, and then our terminal CH3. This is an alcohol. And so constitutional isomer, we have 1, 2, 3, 4, 5 carbons. So let's just draw it straight, and then an OH may be connected to the middle one. Last two problems, we have a CH2 on the left, then a CH, then a CH2, and a CH2, and then over here CH2, CH2, and then our final CH3. So a constitutional isomer, well, first of all, this is an alkene. Constitutional isomer that we can draw is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 carbons. And so literally just put your double bond anywhere else, anywhere you want. In the next problem, we have CH3, and then CH2, CH2, CH2. We have a CH2, and then a CH3. And so this is definitely an alkane. And a constitutional isomer that we can draw is literally any other alkane with 1, 2, 3, 4, 5, 6 carbons. And so what we can do is maybe 1, 2, 3, 4, 5, 6, something like that. That works. The next problem we have CH2, and then a CH, CH, and all the way at the end a CH2. And this is definitely an alkene. I'm going to stop here and kind of warn some people that this could be called a diene because you do have two enes or two double bonds. I'm going to call it an alkene. I don't think any orgo courses at this point would give you a problem like this just because, you know, it is kind of confusing. It goes both ways because we don't teach you what dienes are at this point. But a constitutional isomer that we can draw for this one is we'll realize that these two double bonds can kind of add up to a triple bond. And so a constitutional isomer that we can draw is still 4 carbons and then just add a triple bond kind of anywhere. That's an easy one. And now this last one that we can kind of realize that we have CH, right? This one, for example, it has a branch point of CH3. It's connected to a CH2, this one, CH2, this one, CH2, which is this one and this one, CH2, and then a final CH right over here, which has a CH3 branch point. And so this is definitely a cyclic alkane. And so really easy constitutional isomer that we can draw is let's just redraw that cyclohexane, and then instead of having 2 carbons off to the sides, we can just have the carbons, you know, as like this. And that should be a constitutional isomer. This concludes the huge worksheet on alkyl halides, alcohols, and ethers. If you're unfamiliar or not sure with any of these concepts, go back to the topic video and rewatch that and maybe retry the worksheet. And I'll see you guys in the next video.